In this lesson, I'm having students graph quadratic functions in standard form. So standard form for a quadratic function is y equals ax squared plus bx plus c. And y equals x squared is the parent function, so this is one that students should know on all three forms that we're graphing. For standard form, the vertex is found by the opposite of b divided by 2 times a, and f of opposite of b divided by 2 times a, which I told them to write down in their foldable the previous day, but we really haven't went through what it is. So we talk about how a is the coefficient in front of x squared in standard form, but it has to be in standard form with everything on one side of the equation set equal to y, or 0 in some cases when we're solving. So a is going to be equal to 1. There is no x coordinate, so b is going to be equal to 0 in this case, and c will be equal to 0. So it has to be in standard form to identify what a, b, and c are. So we first talk about that by definition. And then opposite of b, 0 doesn't have an opposite, so 0 divided by 2 times 1 is just going to be 0. And then when you go back up to the function and you substitute 0 in for x, you're going to see that the y coordinate will also be 0 when you square 0. And so 0, 0 is actually going to be the vertex of the parent function. Hopefully they won't have to go through this whole process. Once we just briefly go through it a few times, they should start to memorize what the parent function looks like. And so the vertex, we're going to put that in the middle of a t-table based on our knowledge of that a parabola is symmetric on both sides that we talked about the previous day. And if we pick a couple of x coordinates on each side of the vertex, so if I selected -1 and 1, whether you put -1 in for x and you square it into the function, you'll get a +1, or if you put a +1 in and you square it, you'll get a +1. So those y coordinates are all both going to end up being +1. And same thing goes for -2 and 2. If you square both of those quantities, you get a +4. So 1 away from the vertex, you're at 1. 2 away from the vertex, you're at 4. And then I tell them to sketch the U shape of the parabola. Try not to make it V-shaped the best you can, because that's the absolute value function. And then we talk about how that parabola is symmetric. So the equation for axis of symmetry is going to be x equals 0. And then we talk about, from the previous day, just review that the domain of any parabola, whether it's going upward or downward, is continually moving outward along the x-axis. So the domain is going to be all real numbers, or -infinity to infinity. We also studied that in the first unit of functions in this at the beginning of the year. And so range is based on the vertex, the closure of where it starts, and then which direction it's going is depending on whether it's going to positive infinity or negative infinity. So 0 is where it stops. It starts at the vertex, and it's going to be closed at 0 and going upward, so it's going to positive infinity.